So in this video, I'm going to improve the design and make the latency equal to 1, because with every clock cycle with every operation we need to press the button for 3 times, and in this time I will make it just press it like once without modifying or changing anything in the C++ code. So if we can repeat the RTL generate code here, everything is good. So the next thing is I'm going to do right now, if you can see here, like the RTL process only. I need to see the result. Okay, so here as we can see 3 times. I want to reduce this to once, so once I press only once the key, it will display the result. But that will increase the critical path for us. To do this, the first thing I need to do is to set the function constraint, make it manual, and the synthesis, make it manual. And if I go here to this file and open it, so this is the operations that we have in our design. So for the others, I will increase the number of function units to reduce the latency here from 3 to 1. So if it's 5, I'm going to put it like 10. And for this one, I'm going to put it like 8. And for the 16, I'm going to put it like 2. And for the 12, I'm going to put it like 4. And this is the last thing, I'm going to put like 4 as well. We'll apply the change. Okay, let's see what are we going to get. If I go to resynthesis, all right, see, good. We have reduced the latency from 3 to 1, and but the delay have been increased. So I will synthesize, everything looks great. I will go to the to here and make this affected on the result. So think to the software, I need to resimulate it again to see the results, and I'm getting the same error. I will go to the here, make the directory again. Okay, updating build update, and I will run the update now. Good, I get this to check means it's correct. Let's go to the RTL, do simulation. It's doing the simulation and generating the new VHDL, the new Verilog code. Everything went perfect. And if we go to the output right now, to the output CLV, we can see the number has been reduced, and I will take this code and move it to the Quartus. All right, let's see if it works. Sorry, so here I will open it on Quartus and copy it to my machine. So it's gonna take some time to open the Quartus on the Linux server. If I got the JTAG here installed, I will not need to go there. So that's why I'm taking this code and move there. But first I need to check it's working perfectly. It's going to take some time. So now it's generating the QPF file. All right, and it's running the Quartus. I can take it directly from there, but I prefer to do it from here just to make sure everything is working perfect and in a good shape. All right, so I will copy this and send it to my machine. Sorry for you, this very primary. This is Verilog. Right. Yeah, good. I received it here. So once I received it in my machine, I'm gonna work on it and the other machine that I have on my PC. So I will work on it like this is the PC that I have. So this is the PC that I have right now with me. I'm going to go and take the new code after yeah, there it is. Copy all of it. Let's make sure that I'm copying the last part, then go to Quartus and paste it here. All right, paste it. Make sure everything is good. Yes, we got the 7-segment code here. All right. Yeah, I'm gonna save the project and run. Now, it's gonna take some time to be done. And I'll come back again once it's finished. Now the software is working done. And the compilation process is finished. I'm going to upload the SOR file to the FPGA. This is the second one. All right. Delete that. And the SOR file to it. Open. Okay. I think everything is good right now. Instead of doing this, I need to delete this right now. Add file again. For that. Yes, now save. All right. So that's it. Says fail because the SOR file is not in the right place. So I'm going to delete it. And again, yes, now apply this. So it's uploading. All right, cool. So as we can see here, the FPGA board has been worked and it displayed nothing. This is the reset. And if you can see here, the latency is 1. That means once I push the clock here once, it will display the result. So right now I'm giving the result as 128 here. That means the second switch is 1 and the rest are zeros, and it should be display 16. That's why I got the 16 here. So the next I should got the 23, and after that I think this is not correct. I should pass it, and it should be 48. Sorry for this. So I think it's gonna be 48. Yes. So the next one will be 32, and the next one should be 48. Yes, and the next one should be 64 and 18 and 96. So if we can see here, with every push button, it's changing. Well, the first video we were pushing it like 3 times. So that's enhanced the design in it. So we got the 128. So if we do the same thing for the 255, this is 55, I think 55, sorry. Yes, 55, and if I press the reset right now, it's gone, and I will put the reset like 10. We can see here, so see 31, pressing resulting 31. We compare the result with the, if I press it like 163, another push 95, 180, 150 till the exact result. And in this way we optimize the design and make it like the latency, it will finish at 1 clock cycle as here. Thank you for watching.